Hi everyone. Um, I think we're going to start right away. Um, da, da, da. Okay. So yeah, this is supposed to be a mix of um, solution and bug fixing. It's not much of a introduction to any problem. So if you have any challenges so far, if you have any tasks, any problems, you can bring it forward and we can solve it. You can also use the chat if you are shy to talk. Otherwise, yeah, I'll be willing to hear any comments or options you have or queries you have. Hello? Can you guys hear me? Maybe I'm too low.
I can hear you, sir.
Oh, okay. My volume is actually very low. Oh yeah, but I could hear the last person. Um, okay, we have 4B and Richard. Okay, looks like nobody wants to talk.
Okay, sir, I have a question.
Okay,
Oh, let's say questions. So
yeah,
the
go
first
ahead.
is that um I have my learning part is R.
Yeah.
I'm learning the R language.
Mhm.
And there's this else if statement, if else if and else that I
Mhm.
learned.
Mhm.
So I have the R installed on my system, right?
Mhm.
But the else if is not functioning to just give me error message. Then I
Nice.
now found out that there is if else.
Mhm.
So my first question is that is if else equivalent to else if?
Yeah, in principle.
Is it the same thing?
Yeah.
Because when I use if
But the use of if else is a little bit tricky. If you don't know how to use else if, I don't think you should use if else outrightly.
I can use else if, but the else if is not functioning on the R that
There's
I have on
no
the system. But it's functioning on the Hack Bio platform. It's working fine there. But
probably type
when I
it.
try to use it on the R that I installed on my system, it's not working.
Do you have a do you have can you share your screen?
Actually, I'm using my phone right now for this call.
If you need help with something, it's better you use your computer. But it's
Oh,
fine. Anyways, you can share the screenshot later on the help channel. But yeah, else if is
let me
it's
try to
else if
see if I
everywhere.
can
We are probably
join.
missing it's a syntax error. It's just we are missing a square bracket or a curly brace or something.
Okay, let me see if I can join using my system.
Yeah, if you can, it would be nice, and maybe others can also learn. Okay.
Okay,
Yeah. Also, what's the second question? You said questions.
the second one. I'll skip my mind.
Okay.
I'll ask when I remember.
Yeah, when it comes back.
Okay.
When it comes back. Okay. Check how many people do we have in stage 2 by now? Ah, we have a lot of people in stage 2 already. 146 people. Oh, I thought we were far off. So we were barely 60 people who are left to promote. That's nice. That's really cool. I was not following because yesterday I just blacked out because my hands were literally amputated. But no, they were not cut off. It was just anesthetized, so I couldn't lift it so much. Okay. Um, we are waiting for happiness, but in the meantime, does any other person have a question? Or if you have 146 people that are promoted, it should be nice to have someone who wants to volunteer to solve the task for us here. Okay, looks like nobody wants to volunteer. Oh, let's see if, anyways, I'm using a local deploy. Let's see if I can solve it. Hopefully, I believe I should be able to. Um, where's my screen? Okay, so I'll try to solve. Can you guys see my screen? Oops. Am I commenting? Yes. Okay. Okay. So why are people leaving stage 1? We did not ask anybody to leave stage 1. Okay. For translate. Oh yeah. Okay. So here's the thing. I would do probably the first two with R. Let me see the other two. It's actually a long shot. I don't know if I can complete solving them myself. Write a function for determining. Yeah, okay. I can do the remaining two with Python. Okay. So I would just try to be a little bit pedagogical. Like I'll try to break it this step by step, how I would think about it and the process of implementation so that you also see that it's not, I think a lot of people are overthinking the problem. That's one thing. Yeah, it's good to want to solve a problem thoroughly, right? Which is it's a good spirit. But sometimes just do the basics first. Once you are clear with the basics, then you can advance in complexity. Okay. So let's write a function for translating DNA to protein. Um, so I'm just going to do um, a simple implementation because we don't have the time to build the biggest um, to build the biggest, what's it called? The biggest so data frame. I can't sit down and write 60 amino acid triplet codons right now. So I would simply say I'm searching for the the triplet codon table. Yeah, basically I'm going to use R first. So I'm going to create a simple vector database. It's basically C. You define it with C. So let's say our codon DB, assuming DB means database, equals to C into bracket. I can use, so I'll basically just use this first box, UUC, UUU is equals to PHE. No, UC is equal to PHE. Oh, the PHE. UUA and UUG. think that was listen, if I'm correct. Yeah, listen. Okay. Guys, if you have questions, please feel free to stop me at any point. It's not a, since nobody volunteered to solve it, that was why I'm trying to solve it. Probably people would have volunteered yesterday. I don't know. So let's assume this is our database. So you could also do this with your dictionaries in in Python. So let's say, for example, we want to just write a function that picks any triplet codon, just a single triplet codon, and converts it to the amino acid. Hmm? So I'll first of all say function. No, I'll name the function. That's a translator. I will just call it translator is equal to C into brackets. No, function into brackets. Then this. Let's say the function is what do we use? I'll call it input codon. That is, it accepts a single parameter. Yeah, it accepts a single parameter and it spits out whatever it's supposed to spit out. So I would say um, return codon db into brackets input codon. So because we have a minimal database for our codons, I can simply say translator into brackets. Let's say we want to know what UUA translates to. If I run the code, so it returns leucine, right? It returns, it also tells us that you, because this is the way um, this kind of vector declaration works. You can name named vector declaration. It tells you the name that you imputed and tells you the output. So it gives us leucine. But sometimes, or in real life, you are not usually asked to just do UUU. You're probably given something like, um, let's see, you're probably given something like UUU. I'm just assuming everything is U, right? It could also contain UUC. Those contain UUC, right? Assuming this is what you have, how do you break it down first? So how do you translate it? What I would do would be to break it down first into triplet codons. And if I break it down into triplet codons, I would now pick each member of the triplet codon and return it as a protein, as an amino acid output. And then, of course, you join all of this into one and they return a single protein in that sense. Assuming a protein is basically a polymer of amino acids, right? So let's say this is what we are going to check later on. So let's say our test is, no, test codon. Just cut it and put it here. Okay. I hope so far you guys understand, especially those that are using R. Even if you're using Python, I think the idea is still the same. This is just a dictionary in your case. And if you define a function using DEF in your Python code, you could simply just call a database, a dictionary, and call the name of the codon you want, and that will give you outputs. Okay, so this has to be in what's yeah. I'm not seeing any questions yet, so I would assume everybody understands. So first of all, I would break. Looks like question came. No. Okay. So first of all, I'll break this into threes, right? So how do I break it into three? First of all, I'll break it into individual pieces, right? So let's break it down into individual pieces. So I'll say split um, split sequence, yeah, is equals to string split into brackets first. And let's go see. No, no, no. Input codon. It should be input codon, not, yeah, input codon, comma. And I want to split by the spacing, like that is not by spacing, but by the individual characters. If you want to split by individual characters, you just specify a string with nothing in it. Um, so in this case, I'll just mute this, I'll comment it out, and then if I print split seq, yeah. So let's say, for example, we are testing UUA. In this case, we can run it. Should be able to work right. So it splits it into U, U, and A. In Python, I think there is a string. So for every string, you can just put dot split at the end, right? So it should work. So basically we've split it into three. That is its constituents. But you notice that it is sub-indexed into one. All right. So I just copy this index number because it's indexed. That's how string split works in R. So you split it and pick the first index. So if I print it again, you will see that the one disappears and it's just the indices. So one is number one, number two, and number three, right? So what I would do is I have to pick it in threes, right? So how would you pick in threes? Um, I can simply say, oh, sorry. So to pick in threes, I can simply say, hold on, this. So I'm not printing again. So one other thing you need to know that is that while coding, leave as much as possible opportunities for um, comments. This, or I don't call it comments, they are called checkpoints. So if you have an error, you can always trace back. Like, okay, this is where it worked. It is working up to this point, and after this point, it's no longer working. So how do I fix it from this point downward, right? It's one way of always ensuring that your code is still working. Down. I'm getting a message here. Sorry. Hold on. Um, are you guys with me? It sounds so quiet and boring.
Well, yeah, so
Okay, but do you understand, or are you appreciating, or does it make sense so far?
yeah, so following.
Okay. Okay. So let's say I want to pick in threes, right? I remember there is a function called sequence. No, is it sequence? Yeah, it's sequence. And you can use to split any item into its multiples. So let's say I want to print, for example, one from position number one. Oh, sorry, it should be sequence into brackets, one, comma, the length, if my spelling of length is correct, split seq, the length of split seq. So if split seq is 15, then it picks the length of split seq and it spaces it by threes. Is it supposed to be by three? Yeah, I think so. Then let's run the code. I see. So the problem here is that uh, after the first three, there is nothing else. So it says seq, into brackets. The length of split seek in this case is 3. And after 3, there's nothing more. So we'll change this to test CD. Ready? Test CD. We should see, yeah. So we should see 1, 4, 7, 10, 13, and on and on, right? So I would save this as well. Codon start, codon positions. I'll save it as codon positions is equal to, and I can remove these brackets, right? So I have my codon positions that is from 1 to 4 minus 1, right? Then 4 to 7 minus 1, then 7 to 10 minus 1, right? So how do you now pick first 1 to 3? I'd say I can simply use a for loop in this case. For, hold on, sorry. Okay. Okay. Hold on. Sorry, I always get a lot of messages. This is why I also don't usually like to do live classes. For I in codon positions, then you pick I plus 2, right? So I would say I can pick my split seek. So the current, okay, let's just say our ribosome, right? And then say or ribosome output. In this case, you are basically coding the ribosome. That's what you are doing. Ribosome output should be C into bracket something. So I'll previously define ribosome output here to be equal to C, which is just nothing, right? Should be an empty string, and then we add every other thing that comes out of the ribosome into this. So I have to C into bracket ribosome. So as a C into bracket ribosome, then I would now pick, no, I'm jumping a step. I'm jumping a step. So first of all, I have to pick the first 3 items. So let's say current nucleotides, they are C into, no. Yeah, I could say they are split seq, right? The amino acid is split into brackets. No, not into brackets, but square brackets. I to I, no, I plus 1. So sometimes I would say you put it into brackets so that it doesn't confuse itself. So I into bracket, I plus 1. So this semicolon in this case is saying from I to I plus 1. So if, for example, if you say, sorry, not I plus 1, it should be I plus 2. So if, for example, if you say we are starting with position number 1, it counts from 1 until 1 plus 2, which is 3. So it picks 1, 2, and 3. For the next one, it picks 4. Then it counts 4, 5, and 4 plus 2, which is 6. So for the next one, it picks 7, 7, 8, and 7 plus 2, which is 9. I hope it makes sense. So that's how you basically pick 3 things. You see how we came from for loop, and we are using a for loop basically to simulate what a ribosome does. Of course, my ribosome is not perfect, but you understand you can improve it better by yourselves. Okay, so now that we have the current nucleotide, we have to, so here's what I'll do again. I'll print the current nucleotide. So always remember to print in between just to assure yourself that what you're doing makes sense. Yeah, so I had a lot of U's, right? But you notice that the first one is U, of course. And at some point it changed to UUC, and UUC. Interesting. So far, does it make sense? Hello, I'd like to hear some response.
Yeah, it does. It does.
Okay. Any other person wants to comment? Okay, maybe nobody else wants to talk. Okay, looks like nobody wants to talk. Okay, then what I can do if I want to print all these three, I want to convert them into one, right? I can simply say paste 0, right? I don't know if you remember paste 0 for those in R. By the way, so I'll still do it like a clone. I won't do like a clone live, but I'll do a simple clone. I don't know. I think I'm logged out. Yeah. Okay, that's weird. I think someone sent a message. Is there no way for them to appear without quotation marks? Yeah, this is what I'm trying to do now. Interestingly, let's see. I'm coming 0, 1, 1. No, it shouldn't be 0 because this is bar R. So this is also one thing with knowing two languages or more than one coding language. You transfer them into each other sometimes. Ah, okay. So I had to actually print them separately. So because I know they are just three items, then I can paste them into one. And I have you, right? So I would say I would overwrite my current nucleotide and I'll remove print statement from here. I think I don't like this effect. Is it also giving you this white screen? I don't know if it's my computer. Then if I print current nucleotide. So Johnson, did I fix your question? So right now,
Yes, thank you.
yeah, we're able to.
Even though I'm trying to grab it because I started with Python.
Yeah, I can give you a Python alternative, but not live, right? I will just describe what you would do in Python. I don't also have the solutions. I'm just doing it also live right now.
Mm.
Yeah, so I am pasting the individual items because I know there are three, and I paste them together because they can join, and paste 0 can do that for me. So you realize that most of the things that we've been doing so far, they are things you have learned at some point in the course. It's just, yeah, your ability to string them back together. And it takes practice, but don't worry, you'll get there. So then I can activate my ribosome outputs. I will then activate this again. And then my ribosome output, I want to generate codon DB. So instead of my codon DB here, I can cut it out. I will tell it to search inside codon DB and tell me the output of the current nucleotide. And then it attaches it to the growing ribosome output, or the growing polypeptide chain, if you may, in this case. Yeah, then I run it. Sorry, we did not return anything. And then I return ribosome output. And then you run the code. So it gives you phenylalanine, blah, blah, blah. So everything is actually phenylalanine. We did not do any leucine. Okay, let's add some leucines. And no, there's a lot of Phenylalanine already. Yeah, then I run the code again. Yeah, so there are a little bit of leucine, phenyl, yeah. So in your case, what you can do definitely would be to expand the codon database. You should expand it well. I mean, cover all the 20 amino acids. And yeah, if you simply write this, it should work. Some other things, so this is a very, very simplistic solution, right? Some other things you can consider is the length, right? You can you can first of all check how many nucleotides are actually there. Do we have 10 nucleotides? So because 10, you can't, in principle, you cannot split into 10. You can split 10 into 3. Also, you can also say you want to always start from the AUC codon. If you can definitely go and search internally into the sequences and say you want to start, is it AUG rather, AUG codon, and you want to make this your start. So it has to locate this start position before it starts breaking down the amino acids, right? You can also do this, but at a very basic level, this is a very simple solution. And if you do this, you should get promoted. Okay. I'll paste it on our, I don't know, I think I should post it on stage 1, solution in R. Just that people that are joining will see the solution, but yeah, it's fine. Let's see. Yeah. Okay. Is everybody happy with the solution? Do you have any better way I could have done it? Do you have any query? Maybe I did not write some things well. I mean, feel free to also object and query my codes. There's no, yeah, go ahead, Elijah.
Um, what I didn't get was how you formed the codon table. I didn't understand that because from what I understand for vector, they have to be like the same data, like, but this seems like you have like two things equal to each other. I don't get how that's possible.
Do you use R or you use Python?
I use R also.
Okay, so in R, you can have a named vector list, right? So basically, anything in R, you can name it internally. So the way you have a data frame that you have the names for the columns, you can also have that. But it's just that it's one-dimensional, right? You don't have rows and columns. You only have just rows. And it's not even rows, it's just items in one dimension. So you can name each thing. So if you have 60 possible codons, you can name UUU, you can name it aniline. UUC is also phenylalanine. UUA is leucine, like that. And so it's a convention in R. It works in R. And I think we also mentioned it in our course, if I'm correct. I think it's mentioned.
So that means basically
Mhm.
the codons are like names for each of these amino acids.
Yeah.
Okay, now it makes
It's
sense.
just,
Thank you very much.
yeah, it's the way you would do it in dictionaries as well. It's just being smart about it.
I actually didn't think of that to go the long route of using
Yeah,
the
I know
data
many
frame.
people were overthinking it, but yeah, just I always think of what is the simplest solution in coding as long as it works. So this is not like software development where sometimes I mean, by software development, I mean software development at Google, where most of the times you need to write a code, write documentation. Most of the times in bioinformatics, you are the only one working on your code. You are the only one who probably understands the code and you are responsible for everything in the code. So first of all, you have to make sure that it works. Otherwise, you will not, yeah, it doesn't make sense. Otherwise, you'll be accused of fraud in science, right? Okay. Let's try the second one. That's the second task. If there is no other question, oops, we're already way late. We're already too late. I would also like to do something for the people in Python. So write a function that simulates and generates a logistic population growth curve. Your function should include two extra parameters that randomize the length of the log phase and the exponential phase. Okay, I'll just clear this out. So first of all, I'll think of what is, so I know it's a logistic population growth curve anyway, so it's already written in the question. Population growth equation. I don't know. It usually comes out here, but I can't find it. Let's just enter logistic growth. Sorry, I'll just look for it as logistic growth. Logistic curve. Let me do that way. Logistic curve. So I'll just say L divided by 1 plus e raised to power blah, 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 blah. So in principle, to define this, let's see our population maker, right? We call it function into brackets, and then I say, so in principle, if you already have an equation, you don't even, I think this was the simplest task, but many people were overthinking it. If you have an equation comes with a few things. An equation comes with the parameters. So all of these L, K, X, X naught, they are all parameters you could include here. So in my case, I usually use 1 as the maximum population value. That's L, which is the curve's maximum value, like we discussed in the meeting the last time. Let me open, I think it was this image we used. Open image in new tab. Yeah. So L, we always use 1 because it's just something between 0 and 1, right? So it's either 0 or the maximum. It's either all or nothing, right? So we could yeah, so we could, I'm not going to put L because I know my L is automatically 1 for my case. You could also use 2, up to you, but I don't think it makes sense. Then you can say your K. So let's set your K value, logistic growth rate or the steepness of the curve. I know the growth rate of, say, I'll say K, sorry, K equals 2. So I know my K for E. coli, for example, is approximately 2. For bacteria, people in microbiology will probably appreciate this. I'm also a microbiologist, by the way. But I think if you're working with something like tuberculosis, it's like, I don't know. So by 2, I mean 2 per hour. That is 2 cells come out per hour. No, is it 2 cells per hour or 2 generations per hour, something like that? I can't remember. But for what's it called? For tuberculosis, mycobacterium, it's about 1 per 24 hours. And it depends on the strain, actually. So could be complicated. So I'll say my K is 2 and my X naught rather, is the midpoint. So let's assume my X in this case, X initial, X mid, they call it the midpoint. I'll call it, so it's going to be in hours or in time. So let's call it 5. Actually, this can also change, but yeah, let's leave it at this. Then I can simply return my solution. Let's say my solution equals to, in principle, I can also use the regular equal to already. I can say, so basically, I'm just going to be very simple and just create exactly what we have here. So let's say I have I have so 1 divided by, I would open a bracket, 1 plus, I would open another bracket if I'm correct. No, sorry. So exponential, I think, I'm not sure if let me be sure. Exponential, yeah. Exponential is actually a function in R. Exponential. So I need to have an x value as well. X. So x can be starting from 0 and up to, I don't know. So exponential of, what is this? Exponential of x minus x underscore mid, right? Right? I'm not doing anything out of the books. So basically, I'm writing this equation or this numbers, this formula, this mathematical thing. I write it in R. And basically, that's the solution. I know many people were overthinking this problem. But that's why I give you the equation, and I was expecting that at least just make a simple replica in R. If I give you an equation 2 divided by 3, just write 2 divided by 3. So let's say, for example, we have population maker into bracket. Let's say our k equals to 2. Let's say our x underscore mid equals to 5 as we've written here. And let's say our x equals to 10. No, it doesn't make sense. Let's say x equals to 0. And we run the code. I think I like that. Sorry, I'm on a local deploy, so it's even worse. Yeah. So our y-axis value, that's if we are plotting the curve, our y-axis would be 0.99, almost 1. If I change this to 3, yeah, it reduces. If I change this to 56, so these are just random values, right? It becomes this. Anyways, let's try to, so I know you don't know how to plot yet, but I'll just put it on a plot, right? But one thing we can do is you make a for loop. So first of all, I would say OD, let's assume we are using OD. I mean, OD 600, for those that know what it means. Let's say our OD 600 is equal to empty, right? And then I create a for loop that starts from, let's start from 0 to, let's say 24 hours, bacterial growth curve from 0 to 24 hours. And then we put it in, we try to, no, sorry, what did I do? For I in, actually, I was correcting someone for that mistake and I'm making it. So for I in 0 to 24, we now put our population maker. So I'm already trying to solve question B, for those that care to follow. And instead of having instead of having 56 here, I put I. And let's see what comes out. What's wrong? The code. What's wrong? Okay, I'm not printing it actually. I was expecting it to be printed. Yeah, I say print. Let me see. Yeah, so you can see that it's gradually reducing. 0.9, it rapidly reduces anyways. Rapidly reduces. But yeah, we can, in principle, get a curve out of this. And to get a curve, I would say current OD equals to that, and yeah. And then I would say I have to also, so we already know that we are plotting between 0 and 24. That's our time. That's X value. And we know that we are generating the output. That's our Y-axis to be current OD. So in principle, you can say plot, since we are in R, you can simply use plot actually. Sorry, I didn't do one more thing. I have to append this C into bracket OD 600, comma, current OD. So basically, like we did in the previous question, where we were just appending the current outputs to the growing chain of outputs. So it's still the same principle. So I can say plot x equals to, so my x-axis is going to be 0 to 24, and my y-axis is going to be current OD, and then I run everything. Okay, it's telling me there's an error because x and y differ in length. Okay, hold on. I try to see where the error is coming from. So first thing first, I'll print the length. So it's because it's telling me that x and y differ in length. So I'll check the length, obviously. Print length of, I want to print the length of OD 600, and I want to print the length of 0 to 24. Run the code. So both are 25. This is not making sense. Okay. Who could figure the error for me? I've seen the error, but can anybody detect it? Anyways, to avoid time wasted, I was printing only the current OD, not the fully appended thing. Okay, if I run it, okay. I think there is an error because this is the negative logistic curve, right? But you can, I think you have to correct one of these items to negative. Let me be sure. Yeah, negative K.
The negative K was not captured.
Yeah, thanks. I don't know, should I? Okay, I actually did not include K in my equation. That's bad. Exponential of, I'll put this into another bracket. Yeah, oops. Yeah, and then I'll say minus K. Then I'll run the code again. Will not find function K. Well, yeah, multiplied by. Yeah, you see, I have a semi-good logistic curve, but yeah, it looks like something, right? So it looks like something. How do you now create multiples that shift between from 0 down to, basically you are shifting the midpoint? That's basically what I asked you to do. When I said that's the B part of the question, it says using your function, generate a data frame with 100 different growth curves. So it's already easy first because you know that we already set the midpoint to be 5. So if the midpoint is 5 in this case, you can easily shift it around. That's a very easy, cheap trick. You can also change the slope to make it look different. That's another very cheap trick. So in principle, I could say, so for I in, so I could just keep my X to be 0 So X could be changing. X has to change, definitely. But then I could also vary my, let's say I change my X mid to 7. No, so it would change visibly. If I run the code, you would see that it has shifted a little bit to 10, right? If I change my growth rate, if I change my growth rate to 0.5, which is, I don't know, yeah, you see, it looks even more natural. It looks a little bit more interesting. You could also change this to 0.25, sorry. Yeah, it's looking ugly, but it's something. So basically, these are the, uh, this is a way of, yeah, thank you, Juliana. Thank you. I'm seeing your comments. Thank you, Polo. I forgot the minus K. Yeah, but yeah, in a way, we are able to simulate it basically with a simple function. You don't overthink it. That's one keyword. And now you see how to convert from a simple equation. If I give you the Einstein's equation, I believe you can write a function for Einstein's equation now, right? Okay. If someone defaults, I think that's what I'll give the person to do. But I think that's the simplest thing. Okay, I'll copy this as well and put it on our. I see that you want me to do task 2 using Python. Why? I mean, it's okay. But if I have to do task 2, then I may not be able to do 3 and 4 because we're already 7 minutes down. Do you guys agree? Anyways, task 3 is already so easy. You just have to calculate 80% of this and determine the the time axis, the x-axis. Okay, I think Johnson agrees that we should use Python. Okay, then. It's been a few times away since I used Python, but I hope I can remember. Yeah. So basically, we do the same thing, right? I'll use population maker again. Ah, I'll use population maker again. No, sorry. This is the problem. It's supposed to be def population maker, and you could have parameters. So let's say your parameters are the same thing, if I recall. So you have to select k equals to 2, x underscore mid equals to 5. And let's say we want to keep our x angle, right? Then, oops, yeah. So in Python, you remember you have to put your indentions. They are very important. So in principle, you can just say your solution, right? I'm just going to use the same approach. It's going to be 1 divided. No. Okay. Okay. Yeah. 1 divided by 1. Sorry. 1 plus. Sorry, I have to attend to something quickly. Just a brief minute, sorry. Sorry about that. Yeah. Yeah, so we have to find a way to specify exponential. I think probably exponential, we have to import math. I'm correct. Did we cover important math? If we did not cover it, I apologize for it, but you could have also said, the only thing we did not want you to use was NumPy and pandas and all of that yet. I hope some of you were good enough to. But anyways, you could also calculate the exponential of some values and automatically put it there by yourself. So what I'll do is math.exp into brackets. So what we want to do, if I remember the equation, is negative of k, negative of k, which we have up there, multiplied by x minus x naught. X minus x. That's mid, right? Okay. Then you can simply return solution. Wait, am I supposed to put brackets in return? I don't think so. But if I make a mistake, I would say it. Okay. Let's call population maker. Population maker. And we have our k equals to 2. X underscore mid equals to 5. And x equals to, say, let's use 10 again. Yeah, okay, I remember this error. So in Python, you can't just you can't just specify things. You have to specify the ones that are not default parameters first, then you specify the ones with default parameters like k equals to 2. So this comes inbuilt with the function. It's not smart, but yeah, I have to print again. I guess you people also make this mistake, so you can't blame me so much. Yeah, you see, the solution is almost the same if you start with 10. Now, you could, like we did for the last case, what was the question again? You could, yeah, you could do for 0 to 24, basically. So for I, so let's say we have our OD 600 again equals to, we use a list. In principle, I may not generate, I don't know if I can generate a plot here without importing pandas. Yeah, I can't. So I'm not going to plot anything for Python people. But yeah, you would basically, it's the same output. So you can extrapolate. But next stage, you'll be able to plot and you'll be able to solve things by yourself. So let's say OD 600 is empty for now. And I can say for I in range, if I'm correct, 0 to 24. And I think the stepping is 1 already. You have to put your tab because Python is a very, very crazy language. Then you can say OD 600 dot append into brackets population maker. So you say your k equals to, no, in this case, your x has to come first. X equals to I, then k equals to 2. So happiness solved the else if situation. Yeah. Typically, yeah, it's sometimes you just have some issues. You think it's only you, but it's only you. So an x mid is 5. So you can simply append. And basically, you can print OD 600. Oops. No. OD 600. And then you run it. Yeah. Okay. Yeah. It's very boring, but it's a very long stretch of items, 0.999. Oops. Yeah, okay, so it starts from 0 and gradually increases up to 1. It never really reached 1, but it's 0.9999, which is approximately 1. Did that help anybody? Any questions, any comments? In principle, we could also plot it in pandas, but I don't want to go through that route. Or Seaborn. Maybe you also want to see it in Seaborn. Import Seaborn. SSS, if I'm correct. Hold on. I have to check the Seaborn documentation quickly. Okay. Yeah, I think it's, you can use SNS to scatter plots. Oh, yeah, I could see. Okay. I think I could also use line plot since it's just a growth curve. And I'll see my x. X will be range of 0 and 24. Oops. So that the people in Python will be happy. Comma. So you realize I'm doing some things. Probably I wouldn't have done them if I was coding on my own, but I'm doing some things to let you know that they are not wrong if you do them. Like I'm copying and pasting my exactly what I wrote elsewhere and I'm putting it there. Nobody's going to arrest you if you do that. I know beginners always have these issues with, I'm copying. No, you can copy your code. It's your code. You wrote it. Yeah, you wrote it so that you can always use it. Okay, sorry. This should be wide. Oh, yeah. Okay. You can see it's, I don't know. I think this is even more beautiful than the R one. Yeah, it looks more beautiful to me. If I change this to 7, oh, sorry, I can also change this to 10, and I will change the growth rate to 0.5, you know. So Python is a little bit slow, yeah, but you can see we have a nice curve here, right? Is anybody in agreement that we have a nice curve here? Better than that of R. Probably I should have also, I can't hear you.
The plot looks beautiful, even though I use R.
Okay. I mean, we could also create a similar version for if you're jealous. Okay, so I'll copy the code as well. I think even Python seems more simpler. But Femi and every other person who wanted a Python solution, I hope this kind of helps. I would copy
Yeah, thank you.
yeah, I'll copy the R code. Hold on. I'll copy the R code and I will generate it again so that we can also put the curve, but then I'll make it, don't worry, you'll learn about this next week or already this week. Then you run. You see, you can also put colors. Let me give you some teasers into what's coming up next week. You can also put, say, color red if you want. I don't know if red is a good color. Nah, I'm going to change this to 5 so that it looks nicer. You see? I'm going to use red, R for red, you know. Let's see if I can also increase the width, the line width to about 4. I just want to increase the thickness of the line. It's looking more beautiful. And I can see my title, which is the main. to be the logistic curve. Okay. You see, we also have a logistic curve on top of that. So next week, I mean, the next task is basically you plotting a lot. So you are going to do a lot of this. Don't be happy that I'm doing it. You are going to be the one doing it next week. I'm going to see if I can still edit this and add the plot to it. Unfortunately, I can't. But yeah. Yeah, you can manage it. So basically, you can differentiate the one in R and the one in Python. And you guys can vote on the most beautiful one. Okay.
The axis, can they be named, or the units,
Yeah,
can they
definitely.
be included?
Yeah, you can do all of that. You really want to see that? You know, if you allow me to do more work, you do times 2 next week.
Yes, sir.
Okay, X lab. That's your X label. Is what's our X label again? We wanted to use time in hours. And you can see Y lab, you can already imagine. Sorry. Is equal to optical density 600 or population density. Let's just use something general. Density. And you run the code. You see? Are you happy? And I can just replace this so we don't have too many messages. Yeah. Yeah, okay. I think we did a nice job for the first 2 tasks. Maybe, I don't know. I would have loved to cover more, but the Python guys said no. But probably you guys could, the last 2 tasks are very easy for you guys. I mean, I'm already overboard. The solution to task 2 looks Greek. Really, still without the explanation? Don't let it look Greek, please. It's English. We're already way past time. It's usually a 1 hour meeting. We can do another one tomorrow if you prefer, and just solve this task. But then again, today's Tuesday, so tomorrow is Wednesday. We will release the task for the next stage tomorrow, because we already have 150 people approximately that are promoted. So I would say we would solve, we will do the remaining 2. The thing is, I was looking for volunteers who could code the other part, but nobody wants to volunteer. So I would see if we could cover. I mean, the first task, I don't think we need to do it again in Python because it's basically the same principle. But the final part, which is the arming distance, is what I think we should cover because it's a little bit more logic. I mean, it's a little bit more difficult than the rest. So yeah. Okay. If we have any other questions, otherwise I will stop sharing and we can call it a day. Mm. Okay. There's no other questions then. I stop sharing my screen. And tomorrow we'll try to attempt the last task. Hopefully everybody is. Yeah, you're welcome. Thanks for coming. Yeah, okay. Phobia has some comments. Go ahead.
Yes, thank you very much, Mr. Wale. Thanks, those that attended. Richard, I cite you.
Anyway, what I wanted to say is I discovered that many of us, for those that I met one-on-one on our call concerning this particular assignment, I discovered that you were a bit overcomplicated about how to solve the task. I remember the last two people I met trying to solve a simple task with a complex approach. I don't know whether Wally also experienced or Richard experienced such.
Yeah, similar. It's one of the things I try to approach with this.
Yes, so it's a simple task. The entire program is basic, right? I want
Okay.
to say for those that attended the last one we did, I was late last year, Richard, say that. Yes, it was more advanced, every task given to them, and we have to let them know this is what is you are supposed to say, give us this. But this one is just a little bit tricky. You might
Yeah.
see it as if it's not straightforward, but if you look at it critically, you see that the solution to this is very small. It's at the tip of your finger. But when you look at it overly complicated, then you'll be thinking of a very big answer. So it's not like that. Yeah, for the last two people I met, when they gave me their code, I was like, you are not coding for a skyrocket science. This is what you're supposed to do. One or two, three lines, your problem will be solved. So please, it's an elementary class. So if you think beyond the answer, you leave the answer behind. You might be thinking, yes, you might still get it, but if it's too complicated, then it's not elementary. So I'll beseech you that you look at the question that will be asked critically. Just look at the trick. It's not to bamboozle anybody. So that would be my general comment.
Yeah, very good comment. Thank you very much for that. Of course, we put in a little bit of trick, but the trick is not exactly trick. The trick is just things that a biologist would understand, right? Uh, so don't try to overcomplicate things, right? Just solve it. Think of the easiest way, that dumb or stupid way that you think could be used. I think that's even the best answer sometimes. It just makes things easy for everybody. So for your solutions, we really don't need the plots because the plots are not part of the solution. I only did that so that you can see the output of what you generated, right? It's not a requirement for promotion. Okay. I hope so we recorded this. You can rewatch and it will be online in a few minutes, so you could catch up again. Okay, then have a nice weekend. No, not yet weekend. It's the beginning of the week. Have a nice rest of the week and watch out for more tasks next week, in the coming days. Bye.
Okay.
Yeah.